Finally, this is the grand finale. The latest IPCC report from the 6th assessment cycle finally tells us what precisely we can actually do to fight climate change and avoid catastrophe. What works and what doesn't. So let's get right into it. The first thing to understand is that there are a lot of acronyms in this report. GHG, CCS, CDR, SDGs, FOLU, and we'll define each of those in due time. The second thing to understand is that GHGs, or greenhouse gases, those emissions are still going up. The first and second reports went into great detail about how exactly we know this and what effects this will have. They define net greenhouse gas emissions as the difference between the release and the removal of greenhouse gases, both natural and anthropogenic. And again, they remind us that it's not just CO2, it's all of these. You see, they're all going up except for that slight dip in 2020 from the global industrial pause due to COVID-19. Now, they poured over tons of data sets that go back all the way to 1850 and beyond to get an accurate picture of what exactly is and has been floating around in our air. So where is all this carbon coming from, you ask? Well, 34% comes from the energy supply sector, 24% from industry, and 22% from agriculture. Those are the big three. Urban centers account for the bulk of emissions, nearly 2/3, or about 29 gigatons of CO2 equivalents in 2020, which is not surprising. Wealthy people and nations account, again, for the lion's share of emissions per capita. In fact, as global per capita emissions rose from about 7.7 to 7.8 tons of CO2 equivalents, those figures are about 2 to 5 times higher than in developing areas or low-income communities. Now, the top 10% of households with the highest per capita emissions, people like in my demographic, contribute about 40% of total emissions. Now, the bottom 50% contribute less than 15. Now, these charts just demonstrate how much North America and Europe have dominated emissions going back all the way to 1850. They account for almost 40% of total global emissions to date. Today, East Asia is the current emissions leader with 27% of emissions, but only 12% historically. Now, there have been some glimmers of hope. For one, the rate of emissions year over year is slowing. For the math types out there, that means the slope is less, but still positive. Even still, in the last decade, emissions were 54% higher than in 1990. Also, energy per unit GDP actually decreased 2% per year in the last decade, as did carbon intensity, due mostly to transitioning from coal to natural gas and increased use of renewables. So the world is overall becoming more efficient. Also, government policy has been influential. And I quote, "Policy packages tailored to national contexts and technological characteristics have been effective in supporting low-emission innovation and technology diffusion. Appropriately designed policies and governance have helped address distributional impacts and rebound effects. Innovation has provided opportunities to lower emissions and reduce emission growth and create social and environmental co-benefits with high confidence." Well, that's all great, but is it enough? No. Hard no. You see, current policies will not achieve our SDGs, or Sustainable Development Goals, aka they don't really work, and here's why. You see, there are a few gaps between the policy targets and the sciencey targets. Let me explain. Policies implemented by the end of 2020 are projected to result in higher global greenhouse gas emissions than those implied by NDCs, or nationally determined contributions. These are the pledged emission limit for each country. So that indicates an implementation gap between what's promised, what we're actually on track to emit, and what we need to emit to reach temperature targets. Looking at the models, the nationally determined contributions that are currently committed already underestimate what we're on track to emit by about 4 to 7 gigatons. Now, if we compare those NDCs, which are already a little optimistic, to the targets to keep us under 2 degrees centigrade with 67% confidence, well, we're emitting about 6 to 16 gigatons too much per year to reach that goal. And if we want to keep 1.5 possible, get this, we're about 16 to 26 gigatons of CO2 equivalents per year, too optimistic for that. Now let's take a look at this chart. I know it's a bit overwhelming, but this is kind of all you need to know. The amount of tons of CO2 we can emit per year by 2030, 40, and 50 are all here. If we stay under 31, we can actually hit 1.5. If we emit 60, we likely won't stay under 4 degrees. So where are we now? All the way down here, about 55 to 57 gigatons per year of CO2 as of 2019. So we fall somewhere in this deep maroon territory. Now, in my previous video, where the estimate was more like 35 to 40, that was only CO2, not all greenhouse gases for all CO2 equivalents. That means that the chance we stay under 2 degrees based on our current emissions is about 8%. now for those visual learners out there, I have some graphs for you. See, this red line is the trajectory based on our current policy, as it is today. The dark blue line means we stay under 2 degrees, but don't get our act together by 2030. This overshoot phenomenon is likely unavoidable and perhaps one of the most likely scenarios. Now, the green line says we stay under 2 degrees, but get our act together right now. And the light blue means we limit emissions to 1.5. You see in that graph, it implies we almost start dipping immediately, like yesterday. Now, all these lines represent commitments up until the COP26 conference last year. So for the best case scenario, including those new regulations, we may be closer to 2 degrees or maybe as low as 1.8 if all these parameters are kept up with.
Not great or terrible.
So what does work? Well, number one, low emission technologies work, and they've gotten a lot cheaper. Solar, for example, has fallen 85% since 2010. Lithium-ion batteries also saw a nice 85% plummet in unit costs. Interesting how the market just works out. Also, in particular, wind and solar will have added benefits to air quality and health, and their long-term economic attractiveness depends inter alia on policy design and implementation, technology availability and performance, institutional capacity, equity, access to finance, and public and political support with high confidence. So inter alia is the word of the day, meaning among other things in Latin. So that means this is a multifaceted approach, but certainly electrification is key. Also, to my surprise, the ubiquitousness of small digital computers everywhere. This Internet of Things may actually be a help to the climate fight. For example, sensors, IoT, robotics, and AI can improve energy management in all sectors, increase energy efficiency, and promote the adoption of many low-emission technologies, including decentralized renewable energy, while creating economic opportunities with high confidence. However, some of these climate mitigation gains can be reduced or counterbalanced by an excess in such demand for goods, so we have to be mindful and keep things in check. But that Nest thermostat, it actually does help. Number 3, EVs work. Electric vehicles powered by low emissions electricity, that's key, offer the largest decarbonization potential for land-based transport, period, on a life cycle basis with high confidence. Costs of electrified vehicles, including automobiles, 2- and 3-wheelers, and buses, are decreasing, and their adoption is accelerating. But they require continued investments in supporting infrastructure to increase scale of deployment with high confidence, and advances in battery technologies could facilitate the electrification of heavy-duty trucks and complement conventional electrical rail systems with medium confidence. Further deployments in material and supply diversification and circular flows can reduce the environmental impact of material concerns and risks. So this debunks in part the theory that lithium mining is a net environmental detriment. They also suggest EVs are better than hydrogen power for land-based transportation, but hydrogen could have a meaningful impact on aircraft emissions with biofuels. Now, overall, transportation emissions need to fall by about 60% from 2020 baselines by 2050 to stay under 1.5 degrees. To achieve this, changes in urban form, in combination with programs that encourage changes in consumer behavior and investments in public inter- and intra-city transport, can further support the shift to less greenhouse gas intensive transport modes with high confidence. So EVs are helpful, but kind of a stopgap. Overall, society needs a push towards public electrified transit. Number 4, government policy, as I mentioned before, in and of itself works. It just has to be implemented properly. But the idea that governments can propagate effectual change with the environment is true. They have and they can. And they are absolutely necessary if we're to achieve these large-scale sustainability goals. Government policies and regulations have nudged society towards renewables, largely due to the standards laid out in the Kyoto Protocol. The growth of such policies has grown substantially, up 60% since 2013. However, current regulatory measures like carbon taxes and cap-and-trade schemes only account for about 20% of global emissions, which I thought was interesting. However, new legislation currently being debated could cover up to 56% of emissions, but enforcement is still lacking. All right, so what doesn't work? Well, for one, the continued installation of unabated fossil fuel infrastructure will lock in greenhouse gas emissions with high confidence. Big surprise there. Also, carbon subsidies don't work. That includes natural gas. Now, they acknowledge that the cost of abandoning current fossil fuel infrastructure could cost at least $1 to $4 trillion over the next 30 years. It seems like a lot, but still less than the expected cost of not limiting warming below 2 degrees once the risks of climate-related natural weather events and disruptions are accounted for. Now, keep in mind, the U.S. alone passed a COVID relief package in 2021 costing $1.9 trillion US dollars. So even $4 trillion globally over 30 years isn't that expensive in the scheme of things. Removing fossil fuel subsidies would reduce emissions, improve public revenue and macroeconomic performance, and yield other environmental and sustainable development benefits, and can cut global emissions by 1 to 4% today and 10% by 2030. These subsidies don't work. Where nations would suffer by these lost subsidies, redistributing those saved costs could be helpful. What else doesn't really work? High design carbon capture technologies, or CDR, carbon dioxide removal, or carbon capture and storage, or CCS. Bottom line, we need to cut emissions first. Expensive technologies probably aren't the best ways to tackle this problem. We just need to stop carbon emissions as cheaply as possible. Now, it's true that the deployment of CDR to counterbalance hard to abate residual emissions is unavoidable if net zero CO2 or greenhouse gas emissions are to be achieved. But the scale and timing is the main limiting factor. We don't have the time or money to invest in these not yet fully operational modalities, and we are better served to cut emissions primarily with things that work, like solar and wind, rather than hope for CDR or carbon dioxide removal to save us. It just can't, not today. Now, it doesn't mean we shouldn't plant trees or preserve forests. Obviously, we should, and that's important, but those fancy carbon-sucking machines will be helpful decades from now, not today. Any overselling of CDR as a solution to climate change is just gaslighting. And Adam Clark has a great deep dive into this fact, which I'll link up here. So what else doesn't work is the greenwashing of lateral end-use substitutions for cement, plastic, primary metal processing, and other materials. The chemistry, economics, and scalability of these efforts are too new to make much of an impact, especially when compared to primary carbon reduction at the industrial level first. So unfortunately, simply changing the end product won't in itself do much, but it does send a signal to industry that the public is interested in greener options, which is important in establishing the demand for more sustainable things. So with all that said, what are the most cost-effective solutions? Well, here we see that economic instruments along with regulation can be complementary and effectual at reducing emissions. That includes incentivizing low-cost emissions reductions measures, like the federal tax rebates on solar panels. Carbon taxes and pricing instruments are helpful, but not by themselves without some regulation. But the report stresses how large-scale government and industrial commitments are absolutely necessary. The consumer alone won't solve this problem. So in addition to more government cooperation, which low emissions technologies are also the most cost effective? Well, here we see that all pathways limiting global mean temperatures below 2 degrees, we see that GDP still rises. In fact, the price target is $100 per gigaton of CO2. Anything cheaper than that is cost effective. This chart on page 50 shows us that the longer bars have better carbon reducing effects, and the bluer colors are cheaper. So what's cheap? Green transportation over here. It's not hugely impactful, but low-hanging fruit. What's cheap now and highly effective? Wind and solar. Nuclear isn't as beneficial given the higher upfront costs at larger scales. Some of the biggest impacts are in carbon sequestration in agriculture, limiting deforestation, and ecosystem restoration. That's the AFOLU of FOLU, agriculture, forestry, and other land use, perhaps my favorite acronym of the bunch. Now this chart shows both positive feedback or synergies versus negative effects or trade-offs of a variety of mitigation options across all SDGs or Sustainable Development Goals. I won't review all of them, but geothermal energy, for example, has a neutral effect on items 3 and 6, which is health and well-being and clean water, respectively, but a positive effect on energy costs and sustainable city planning. All right, so in sum, thanks to this working group, we now know what works, what doesn't, how much it'll cost, and when we should do something. All we need now is some demand-side changes where people like you and me are demanding more from our society at large, our infrastructure, our city design and planning, our workspaces, and our governments. In fact, doing so is, quote, consistent with improving basic well-being for all. Several mitigation options, notably solar energy, wind energy, electrification of urban systems, urban green infrastructure, energy efficiency, demand-side management, improved forest and crop grassland management, and reduced food waste and loss, are technically viable, are becoming increasingly cost-effective, and are generally supported by the public. This enables deployment in many regions with high confidence. Bottom line, we need to demand intergovernmental cooperation and prioritization of carbon reduction. So this IPCC lived up to its name after all. Where there is political will, there is a way. One final footnote for the road. Mitigation after 2030 can no longer establish a pathway with less than 67% probability to exceed 1.5 degrees during the 21st century. This echoes my conclusion from my video on the first working group, stating that to hit that 67% probability, we need to emit no more than about 300 gigatons of net CO2 equivalents in total from here on out. If we don't make drastic changes now, we're never going to hit that goal, and there's no way we're going to stay on target. And we also know that CDR won't save us. In other words, it's now or never. So thanks for watching. Hit that like and subscribe button for more sustainable content if you found this video helpful, and comment below on your thoughts on the report. I'll see you in the next one. Thanks again.